So to tell if an integral is 0, we can analyze the function and figure out if it's odd or even. So if you remember, an even function is given if our f of minus x equals f of x. So this means that if we have coordinate system and we have some function that we plug in negative x, so something from the left hand side, that we get the exact same value as on the right hand side, namely a positive value. So we basically just mirror along the y-axis, and this is called an even function. Now an odd function you can identify by plugging also minus x into the function, so some negative value. But then you will actually get also a negative y value. So with even, you get a positive y value, and with odd, you get a negative y value. And on the graph, this would look something like this, where you have positive values here, for example, and negative values here. So we're not only mirrored about the y-axis, but also about the x-axis. And if you now compare the areas, then you can see that the area on the even function is positive on both sides, so we will get something positive as the result. But for the odd function in this case, you can see that on the left-hand side we have a negative area, and on the right-hand side we have a positive area. So these two cancel out, which means that these here are 0. A nice example for this would, for example, the integral from negative infinity to infinity of x over x squared plus 4 to the power of 3 over 2 dx. This might seem a bit convoluted at the beginning, but we can simply do our test. So we can just plug in a negative x, of course, if this is our function. And we can see what it would spit out. So the function, of course, in this case, without the integral. So let's plug in a minus x over minus x squared plus 4 to the power of 3 halves. And note that this here will give us something positive. So we have something negative in the numerator divided by something positive in the denominator, which will give us something negative, namely minus f of x. So this means that this one is odd, which also means that the sum of this integral that I drew on top here is also 0.